Assalamu alaikum, this is MATLAB. In this video, we want to solve the second question of the first midterm exam. So as you see, these questions just examples how we can write, say that the exam questions and how we can use the MATLAB to solve them. In this question number 2, it says that e to the power x is a common. One way to determine its value is by finding a limit. And the limit approximation can be solved or calculated by Maclaurin series, where is e to the power x approximately equal 1 plus x to the power 1 divided by 1 factorial plus x to the power 2 divided by 2 factorial, and so on. Also, we have seen in MATLAB that there is a function for e called exponential. Now write a continuous running MATLAB program. If you see a question like this, keep the continuous running MATLAB to the end. Forget it now. To investigate the value of x using different methods. It prompts user to enter the value of x and then ask him to enter an option from the following. Let me ask user to enter the value of x. This is CLC at the beginning of our script. Clear, always like this, and finally close all. Don't forget comments all always, guys. This is to ask user to enter x. We can say that x equal input. It is an input function that can display a message and show or read the keyboard value entered by user. So we can write, please enter the x value. Okay, then go to next line like this. At the end, semicolon. That means don't show me the result on the command window here. Okay, so we have the value of x, and then ask him to enter one of the following options. Say that we can say option as example. By the way, we can use the, if you wish, we can use option like this, equal input. We can show the message like this, input 1 to print e to the power of x using built-in function. Okay, the actual value. Say that actual to print actual value of e to the power x. Then go to next line. Okay. If you wish, we can don't show me a message again here, the value again on the command window. If you wish, you can print a message, continue printing a message here line by line, or write them all like this. I prefer to say that continue like this. Okay, so here one space, we can say please enter. Okay, then go to next line, one space 1 to print actual value. Remove the value to just make it simple like this, the actual of e to the power x. Okay, one space 2 option number 2 to prompt user the value of n, then find and print the approximation value. To print approximation, say that approximation of, again, it is e to the power x. Okay, then go to next line. It will be a long line like this, guys. Okay, second, to prompt user the approximation using the expression. So to print the expression, say that the expression of e to the power x, which is that one. Okay, and final, choose 3 or enter 3 to print the Maclaurin, I think the Maclaurin series. Use the loop to find the print approximate value of e to the approximation. The last one, it is the approximation. So to print approximation value of e to the power x. Then go to next line, and we have a 4 for exit. 4 choose 4 as you see here, to exit. Okay, like this. Now let me show you the options. Run the program. Say this is exam number 1, question number 2 dot m. Okay, run the program. These are the options as you see. Please enter x value. Say that we have 1. Now please enter 1 to print actual e, 2 to print the expression of e, 3 to print the approximation value of e, 4 to exit. Actually, if I use this way, you have to use switch or if statement, and you can say that if option equal to 1 and so on. But I prefer to show you something else. I will use the menu. Menu like this. In this menu we have please enter is the first or the title. Please enter. I will make it this one as a title. This is the first string. The second string, say the option number 1, print actual value, actual of this one. This is the second string, which is the first option. No need for next line. The third option, no need to say 2 here. Okay, print expression of e to the power x. This is the second option, sorry, and this is the third option. It is print approximate value of e to the power x. Okay, and the final option, it is exit. Press exit like this. Okay, no need to write backslash, and this is just a menu. So this is the title of the menu. First option, second option, third option, fourth option. Okay, now I will show you the result from this. This is 1. Now see, this is the menu. Please enter. When I press print actual, this menu will return 1. When you select the second option, it will return 2. When you select the third option, it will return 3. When you select the last option, it will return 4. Okay, now let me exit. See, option equal 4. Now it depends, we can use switch or F, it's up to you. I will use the switch this time. Switch on the value of what? Of the value of the option. It depends on the option selected by user. This is the end, and here we have the cases. In case that the value of the option equal to 1, I will do the following. Case the value of option equal to 2, I will do the following. Case the value of option equal to 3, I will do the following. Case the value of option equal to 4, I will do the following, which is a break, which is just a break from the loop. I will write the loop later on. So if it is 1, print the actual value of e to the power x. We can say that f print f. Okay, the actual value, the actual value, the actual value of say that e to the power of this value, which is a float value, and say that maybe integer or float, up to you. Say 0.1. I want to use just 1 decimal place. From where I will get this value, it depends on the value of x. Okay, and here we can write equal to this value. Say that it is a float also. Say f, and same thing, 0.1, or in this one say 0.2. From where I get this one, it is from the exponential of x. I will show you the exponential of x. Say that exponential here, exponential of 1, it is this value. Okay, let me run. Okay, we have a problem because here we don't have break. It will not break from a loop, so we have to write a loop. I will write it later on. So I will check them one by one later. Okay, we finished the first one. For the second one, it says that prompt user for a value of n. So here we can say that we have n equal input. Okay, please, the message is please enter the value of n. Then go to next line like this. Don't show me the result on the command window. It's very important. Next step. Then find and print the approximated value using the expression 1 plus 1 over n to the power n. The value of n should be as larger as possible to get the good result. We can assume that here, please enter the value of n as large as possible. Okay, give example, say that يعني 100 whatever. Okay, and then we have the value of n. We can write here ex, the exponential of x, equal to what? See the equation here, it is 1 plus 1 over n to the power of n. So we can write here it equal to 1 plus 1 over n to the power of n itself. Okay, and now we can print the value using the print f function. We can say that the value of expression represent e to the power of x. What's the value of x? Which is a float. It is a float. Say that just 0.1. Okay, equal to this value, which is a float also. Say 0.2. Okay, from where then go to next line. From where I will get this one, it is the value of x. Okay, and second one, it is the value of the expression ex. And let us show also the n, the value of expression represent e to the power x when we can say that when n equal to that integer. Okay, equal when n or 4, say 4 brackets like this, for n equal to this value, equal to this value. So we have this float here, we have to add n like this. Okay, save. I will check this one later on. Or let me repeat, delete, sorry, the break, run the program. See, this is the value of x is 1. Okay, print actual value of x. Good, it is 2.72, correct. But we have a problem here. Let me cancel the here. We forgot to say go to next line. Run the program again. I will use x as 1. Option number 2, print expression of e to the power x. See, say n equal 10. The value of expression represent e to the power 1 for n equal 10 equal to this value. Why not displayed? Why not displayed again? Here there is something wrong in the equation here. It is 1 plus 1 over n. I think this is wrong. I don't know. It should be x somewhere here. Never mind. Let us do it as it is. But why we didn't get a result? Because I think there is a problem here. Yes, it's 0.2. Yeah, by mistake. Should be f. Then go to next line. I will test the code again. Run the program. This is the value of 1. X is 1. Second option, the value, please enter, say 10. Okay, the value of expression represent e to the power 1 for n equal 10, 2.5. No, it's okay, e to the power 1. But what about if e to the power 2, 3? I think x should be in the expression. Anyway, say assume that the equation is correct. Anyway, we increase the n, this value will be more accurate. Let me select x is 1, option number 2, and say n is 100. See, it's more accurate now. Anyway, next step 3, use a loop to find and print approximated value of e and number of iterations using the Maclaurin series. We'll go to here Maclaurin series. So we have to open a loop, in the case 3, 4, say that I equal from 1 to, again, what this loop, see, it is 1 divided by 0 factorial, which is 1. Then, so I here should start, from, listen to me, I will talk about this later. You have 1 plus x to the power 1 over 1 factorial, x to the power 2 over 2 factorial, and so on. Say that before here, write the sum or the result equal 1 to exclude the first term. So I'm excluding the first term, write it directly inside the result. So we have the first term. Second term start from, say that I will use for 1 and 2 and 3 and 4 counter I. So for I equal from 1 to the last, I don't know, say 100 terms. I will talk about this later also. This is the end. I want to calculate the series from 1 to 100. We can say that when I equal to 1, the result equal the old result plus the current term. The current term, as you see, it is x to the power of I divided by I factorial. So it is x to the power of I, okay, in one bracket like this, in one, yes, divided by factorial of that I, like this. Okay, once we finish this loop, we should get the result. Let me continue and see what is the question saying. It says that we have to enter number of iterations. We don't know how much number of iterations. The loop should stop when the difference between the actual and the approximate value, using this series become less than 10 to the power minus 4. So say this result equal to 1. We can say that the difference equal absolute of what? Say that we need the actual, which is exponential of x minus the approximation, which is the result, which is the old result, like this. Then f say that this difference become less than 10 to the power of how much? 10 to the power of minus 4, or number of iterations exceed 100. So or number of iterations, which is I, become larger than 100, okay, larger than 100 if the difference become less than minus 4, or I, by the way, or this is the or, okay, I greater than 100. In this case, I want to break the loop, the for loop. Here I will write break, but in this case this loop should be infinite loop. So where is the loop here? Sorry, this one should be in the loop. Sorry, we should calculate the difference, okay, cut like this, result equal 1, then start a loop from 1 to 100, or I will show you how. Okay, say that if calculate d, if this condition is true, break from the for loop, it will go to here. This is the end of the for loop. Okay, it will break the loop directly and go outside to here. Now we want infinite loop. How we can say infinite loop? We can use while instead. While, we can say while 1, okay, start I from 1, don't show me the result, okay, calculate difference, check this one, then go to here, calculate the result. After that, increment I by 1, I equal I plus 1, semicolon. Okay, now this is infinite loop. It will stop when this condition is true, and this is what we want. If it stop, it will go direct to here. Then here we should print the value. It says that here prompt user to enter, sorry, use a loop, and we have to print the use a loop to find and print the approximate value and how many number of iterations. So we want to print the result. So f print f. We can say that as example the approximation of e to the power of this x, okay, equal to this x, it is variable, so I say this f, okay, and say I want to show just one decimal place, equal this value which is also a float. Say that I want to use two decimal places in this case, or three or four, better, because here you have x 10 to the power minus 4. So let's say that it's 0.4, like this. Then go to next line. From where I will get the first value, it's from x, second value it is from the result itself. Save. And what about number of iterations? It depends on of I. So we can say that Control C, Control V, we got the result, we got the result after, say that, this number of iterations. Okay, then go to the next line. Then I will print the value of I. Let us check this, the third option. Say that the x value is 1. The third option, print approximate value of e to the power x. The loop is running and not stopped at all. That means there is something wrong in our algorithm. C, D, 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 and so on. I will stop it by Control C. Okay, let me check why printing D always. Yes, we have to write semicolon here. Why we got infinite loop? Why the loop is not stopped at all? Again, let me check. The result equal to 1, while 1, I equal 1, d equal absolute of e to the power x minus the result. Now it's 1, e to the power of x, it is 2.7, minus 1, it is 1.7, and this d, it is not less than 10 to the power minus 4. Number of iteration not more than 100. So this condition is false. It will not apply this one. It will not run the break. Result equal the old result plus x to the power of I divided by factorial of I. Let me check the equation here. It is x to the power of I 1, then 2, then 3, then 4, divided by I factorial 1, 2, 3, 4. That's right. Then I equal I plus 1. Then it will come back again and again. Let me check now. Run the program. Okay. Sorry, this is x equal to 1. This is third option. It's busy waiting for the MATLAB to stop. Let me check here. I don't know what's going on. Cancel operation. Let me check D. The current D, it's 2.9 multiplied by exponential to the power 6. The I, it is just 1. Option equal to 3. Result equal to this one. There is something wrong. X to the power 1. Now I just first iteration. Just we have just one iteration. Why we have just one iteration? Result equal to 1. This is result changed directly. While 1 infinite loop. Yes, because the result should be each time. The result should be each time. Let me check. It should be in the while loop or outside the while loop. No, outside the while loop, because we will start result from 1, then start the loop. Okay. I equal to 1, d equal this one. The condition is not correct. Result equal the old result plus this one. Then I equal I plus 1. I think it's correct, but there is something wrong here. By the way, guys, if you have a problem like this, how you can follow your program to see where is exactly the problem. Let me show you how. I will write here. I will use the mouse, click here. So we have this red circle. That means I will run the program step by step. Okay. See here we have run. Okay, now please enter the x value. This is 1. Enter. Okay, now select the option number 3. Select option number 3. Now see it's pause here. Why not showing here? I don't know. Let me check again. Control C. Okay, run. Sorry, uh, run and time maybe. Oh, I forgot. Please let me check. Run section, run and advance, because this is the MATLAB 2019. Go to home. No, it's from the editor, I'm sure. Go to find. This is the steps. Okay, if I have this one, then make run like this. It will run the program step by step. Step by step. It should show me an arrowhead here, and then we can go from one step to another step. Let me check. Actually, I think it is run and advance. Run and advance. The name changed maybe in this version. Let me read here. Please enter the value of x. This is 1. Now I will choose the third option. Okay, not showing again. Control C. Let me check again. Control C. Let me choose this point instead of this point. Run and advance. See, this is 1. Okay, I will select the third option. Control C. I think this is the option, but let me choose this point up to here. I'll show you how we can use this one. Run the program. Please enter. Sorry, not run. Run and advance again. Run and advance. This is 1. See, it shows this arrowhead. That means it go. Now see, continue now, or step. Now it means go to next step. Show this one. Okay, step. Then step. This is the correct case. It will go inside. It's guys, now see the workspace here. Step. Now see result equal to 1. While 1 it will go somewhere else. So this is the problem. That the while 1 it goes to here, then break directly. This is why. Okay, I think the break statement here. So we have something wrong here. Absolute this value, which is the exponential of x, minus the result. See the result value here, it is very large, very large. So the exponential of x minus this value, it will be not less than 10 to the minus 4. I think this thing related to divergence or convergence. So let me change my algorithm. Let me say that while the difference, better choose this one, while the difference d is greater than this value, at the same time the I value less than 100 or equal to 100. Okay, say I equal to 1, calculate the difference. Okay, no need for this one because the loop it will end by itself. No need for this break. I prefer this one, guys. Okay, while the d value greater than 10 to the power minus 4 and at the same time I less than or equal to 100, I equal to 1. I got the idea, guys. Even the previous algorithm should work because we forgot to say I equal to 1 here, not here. I think the previous one should work, but let me continue with this one. This is the problem. The previous I value is 0, and I don't know, even if it's 0. Anyway, I prefer this algorithm, guys. D, okay, I equal to 1. Okay, why? Because when I equal to 1 inside, always I equal to 1. When you come back, I equal 1. It will go to infinity. Run the program. Now I think it should work. This is 1. I will choose the third option, as you see. Okay, undefined function or variable D. This is in this loop while D equal. Yes, we have to define D before, because here we have D. We don't have D. We can choose any value of D equal to 1. Choose a value that makes this condition is true. So as you see, D it's larger than 1, it's larger than 10 to the power minus 4. Run the program again. This is 1. Enter C. Third option, got approximation of e to the power 1 equal 2.71. We got the result after 9 iterations. 9 iterations. Let me, guys, flip the algorithm as before. Again, as I told you, while 1, okay, while 1, here say if this condition is true, but should be flipped, and here end of the f, this should be break. Okay, now it should work, but this one should be the opposite, should be less than, and this one or, because this is stop condition, or I become larger than 100, larger than 100, same algorithm. Now run the program. As you see, this is 1, this is third option, same result exactly. Approximation of e to the power 1 equal 2.7. We got result after 9 iterations. What happened before? Before this I, it is inside the loop. If this I inside the loop, as you see here, each time, see, increment I will become 2, then come back again, I reset to 1. So it will become 1 always. Okay? It will never I become greater than 100. It will not stop. Okay? Because we need 2 conditions to stop it. So I should be outside like this, because just once declare I, define I to be equal to 1, then increment I each cycle. So what about the last option? The last option, if the user select 4, or the fourth option, which is the exit, you have to here write break, but the break, it should be from a loop. Okay, from a loop. So what I will do, I will cut all of these. If you have a loop, you want to say that repeat all of these things, all of these things. Control C, as you see, sorry, cut, not Control C. This is cut. For a loop, we can use while 1 for infinite loops, and this is the end of the loop. Inside this loop, we can paste the code like this, guys. Okay. Now just remove these spaces, and for this one break. Okay, let us check this one. Say now I have 1. For 1, print x, please enter the value of x. Say 2, print this one. Say 3, print this one. Say okay, this is 1, and now select okay, by mistake, guys, I close the menu. Control C, I'll show you again. Run the program. This is x equal to 1, then x equal to 2. Choose the third option. Now x equal to 1, but I don't want to continue. Exit. Okay, guys, do you see the last thing I entered? I entered 1, then exit, but this is not make sense. Doesn't make sense. So I prefer to say this case before cut. In case that the value of option equal to 4, don't ask about the option. Don't show me the menu. خلاص. Don't show me the next step. Just exit. Save. Run the program. Okay. Please enter x. This is 1. Okay, calculate. This is 2. As you see, exit, but same problem. To exit, same problem. So what happening here, guys? While one, I prefer. We have option here, so I will remove this case, guys. I will remove this case. I will remove this case. Okay, and I prefer to write here if the option, if that option equal to 4. In this case, this is the end. I will break. I will break the loop like this. This is make more sense, guys. Okay, run the program. I will show you. This is 1. Now I have the menu. Please enter X value. This is 1. Enter. Same problem. It shows the menu and the value of X. Okay, exit. It will exit. But let me say that make the X, cut the X here. Okay, if the option, and ask about X after this option better. And I think we can now manage it well. Run the program. See here, run the program. I will choose print actual value of X, say X equal to 1. Print the approximation for, sorry for that again. Run the program. I will use the first option, second option for X equal to. Please enter the value of n, say 20. Okay, now exit. See, okay, I prefer to show a message here at the end of the program that we have, after the while loop here, we have to say f print f, that this is the end of the program, end. Then go to next line. I will show you. Run the program, choose this option. Now it is X equal to the n equal 100, and then exit, end. Or you can print a message, you choose the end. Thank you so much. Watch the next video for the second exam.